Hi, welcome. My name is Todd Jersey. My firm is Todd Jersey Architecture, and today we're going to talk about low-cost, high-performance wood frame construction. We've created a system where we've put money into performance and are able to save money in first cost money and your PG&E bill, your energy bill over the use of the structure. We want to talk about now the elements of high comfort, low energy cost construction. What are the elements? So we have 5 of them. The first A is high levels of insulation. So we want what the industry refers to as high R values in our walls. One of the ways we get that is we substitute fiberglass insulation for mineral fiber insulation, which has a higher R value. The other way we do that is typically done these days is 2x6 exterior walls instead of 2x4 exterior walls. The next thing we're looking for, and this is rarely talked about, but this really needs to be a kind of common language for architects, builders, owners, is continuous insulation, or what we call CI. This eliminates all thermal bridging at our envelopes. C in our elements of high comfort, low energy cost construction, which is continuous air barrier below the existing siding, and of course on top of your sheathing, and that's what you're seeing here in red. That's a continuous air barrier. We use Prosoco, Cat 5. This is the Cadillac of air and water barriers. They must be vapor permeable. They also must seal around nail and fastener holes. If not, you have all these punctures to your air and water barrier and they're ineffective. The next really important piece is the use of heat recovery ventilation. When we have a robust continuous air and water barrier, we have very little transmission of, in fact, we virtually no, for all intents and purposes, we have no interior and exterior infiltration of air. You know, the older homes, of course, they leak a lot, right? You're actually getting air transmitting through the building envelope and lots of little leaky holes through leaky windows. These 4, along with a couple others I mentioned, like the obvious, which is good thermal performing windows and doors, which you can't buy something that's not good these days, so I don't have it on the list. But these 4 are part of the passive house sort of strategy for high performance construction. You can Google that, study that. It's a lot to learn in that. I added my own, I added another piece here, which is proper storm water, groundwater, and water vapor management, basically dealing with water, right? That's a really crucial part of high performance construction. This is gonna be up here. And now this is part of what we call building science. So I and my staff and I have studied both passive house. In fact, we are a leading designer in the passive house movement and a leading designer in the building science movement. Building science, you can also, Joe Listerbeck and his Canadian partners. For stormwater management, I always liked their presentation of the 3 Ds. Deflection, drainage, and drying. If you sort of just remember those these are the elements of, for a building scientist, a high performance envelope, right? This is not a thermal performance like we're talking about here. This is a water management performance. So building science is all about water management, H2O and water vapor. So of course we want to deflect, right? We would want to deflect, and of course, what's really the best way to deflect water off our house or our structure is this thing right here, a building overhang. If we don't have it, it's all the more important to understand, to build our walls. If we have sort of a more contemporary thing here with no house here, no overhang, we really have to be studious with how we're building that wall in terms of water management. Drainage. So we want water that will penetrate the deflection systems, such as, especially in this wall. So you might have siding or stucco in this wall, and stormwater beating on that will hit a crack, will get through the stucco, behind the stucco, and this is where we're getting problems. Where water gets behind, this could also happen, of course, at a window. Water gets behind the siding, our deflection system. Whoopsie, you know, here, our water, most of it's deflected, but there's a little crack. Water's dripping down this stucco in, and then it's getting into between our siding and our plywood, which is our sheathing. Right? Here's our sheathing. It sits there, and it causes the dry rot of the sheathing and then the dry rot of the framing. This is bad news. This is where a lot of stucco buildings have suffered, especially since over time the standard building paper they put in on these buildings has essentially degraded to the point of being non-useful. So you get water penetration behind the stucco, it gets into the wood frame, and you get dry rot. And essentially your building is rotting. And this is sort of the negative part of building with wood frame, is it is a subject to dry rot. So what we want to do then is we want to provide a way the water can drain out if it gets in between, and I'll show you drawings, some more detailed drawings. The water can drain out if it gets behind this deflection system or this siding. So we need a drainage, what we call a drainage layer here. Okay, so that's our water drainage. So what happens is if the water can drain there and it doesn't build up, it can dry. So that's our third piece, drying of the building elements that have been wetted by exterior water. Of course, it's easy for the stucco to dry, but it's often hard for this to dry, especially if water is built up. When we add our drainage, we allow the water to trickle down and out at the bottom flashing, out of our system, then the building, it can dry quite easily. So we want to sort of reduce our wetting, but also plan for the fact that it's happened, right? So we're reducing our wetting, and then we're planning for the fact that it will happen by providing drainage, allowing for drying. So those are our 3Ds for water management, stormwater management, essentially. I'm not going to get into groundwater management. That's a whole nother conversation, an important one, but another topic. The other piece that building science covers really, really well is water vapor management. Two really important things in high performance wood frame construction. Remember, we talked about durability. We want our wood buildings to last. We have to allow for interior water vapor in our framing cavities to diffuse to the exterior. So when we build, well, let me just say this and we'll go to the drawing. The second piece is we need to inhibit water vapor generated on the inside to diffuse into the framing cavity. We don't want inside water vapors created by showers and cooking, especially. Human breath. We're building a lot of water vapor in this. We don't want it to get into our framing cavity. If it gets into our framing cavity, it can condense against the sheathing, and then you're getting real issues. Then you've got actual water in the wall, and that causes dry rot. So this diagram is a drawing of a sectional drawing or a vertical drawing of a piece of your house. Obviously, it's not to scale, it's diagrammatic. Now let's just start with sort of the simplest stuff, which is we're going to fill our framing cavities with mineral fiber batt insulation. There's two companies that make it, Rockwool, and I believe Georgia Pacific. Anyway, you can check that. We usually specify a Rockwool, and this is the name of this stuff is Comfort Batt. It's amazing stuff. We don't really have time to get why this is so much, to really discuss why this is so much better than fiberglass insulation, but maybe the most important is that this does not sag ever. It's dimensionally stable over the lifetime. Over years, if you open up a fiberglass wall, you'll see that it sort of sags, and the performance level between mineral fiber and fiberglass is substantial. So we always specify, and this is also fireproof and it's hydrophobic. In other words, it doesn't absorb water at all. If, for instance, we had some kind of break or maybe a plumbing leak, got into a wall cavity, you would not have to replace this because it simply wouldn't absorb the water. The fiberglass absorbs the water like a sponge, creating a water reservoir we don't want. So let's look at some of these elements. We talked about continuous insulation, and so I think I think we already spoke a lot about this. We have our plywood on the exterior. We have our continuous air and water barrier here. It must be both permeable and seal around nails and fasteners. We talked about, we use Prosecco. You can also use blue skin. Here's our drainage layer. Here's our plywood, our air and water barrier, and then this blue squiggly line is a drainage layer or a channel. This can be building paper, which creates a gap between the sheathing and the siding for drainage. There are also companies like Keen, which makes a whole host of rollable drainage mats. Those are super high performance, much more expensive. Typically in our projects, we just call for a layer of paper there. Code requires both the air and water barrier and a secondary layer of paper for stucco siding. So this is required in stucco siding anyway. And then, of course, we just have our finished piece. Now, look at this. If rainwater is getting in here, it's hitting here, it hits a crack like we talked about, and then it hits this drainage layer, and it can basically make its way all the way down and exit at the bottom and out of our assembly. So we're not basically creating a reservoir of water underneath the siding that can't be dried out, right? We're managing that. We've got our deflection system, our drainage system, and then drying, because we have a permeable air and water barrier. So we can dry any moisture that would get in here is able to vaporize and dry out. On the inside, this is where sort of our Todd Jersey architecture magic happens, because we've really pioneered the use of closed cell rigid foam board on the inside face of the framing. Closed cell rigid foam board, like a Foamular, is I think that's GP or L Louisiana Pacific, one of the big companies. Foamular is the brand name. This is Foamular in our drawing. This stuff is inexpensive, really easy to install on the inside face of the exterior framing, both up at the roof ceiling package, along the walls. We use the same stuff to insulate our on top of our slab on grade. Also can be, if this is a wood frame floor, you would put it underneath the wood frame floor. So what we're doing is we're doing, this is powerful stuff. This is creating our continuous thermal break, right? So if we look here, our thermal conductivity wants to go through wherever we have wood framing because it's very low insulating. And it gets stopped at our rigid insulation. There's one sort of fun way to think about how important that is. If you take a cool surface, this is not that cool, but if you take a metal surface and you touch it, you have thermal bridging. You have a conductivity. You're losing your hand's heat to a cooler surface. if you just break that 1/8 of an inch, you feel the difference. That's what's happening building wide. You're breaking thousands of places where thermal conductivity is happening. So you're getting, and by the way, the energy in California, Title 24, has no way to analyze this. So it is a very powerful added level of comfort, vastly reduces your need for mechanical energy, is very inexpensive. And again, the closed cell rigid foam board is also a vapor barrier. So not only are we getting continuous insulation, we're getting an inhibitor of vapor transmission from the inside into the framing. So I made this little diagram here. We get this wonderful cozy interior. Of course, we do need, I should add this, we do need our HRV, right, which is exhausting, and you can look this up more online, which is exhausting this moisture-laden stale air and bringing in fresh air. And actually, the fresh air has to come through the same box. There is a heat exchanger. So our heat recovery ventilator is key to being able to introduce fresh air into our inside. So we're really happy without losing energy. So I encourage everybody to understand, sort of the real basics that we do, which is our rigid foam blanket or jacket, if you will, on the inside, coupled with the HRV. That's where the magic happens. Where we're going to get, we're actually going to get some low cost here, because this performs so well that we are able to, in the Bay Area, where we don't really need cooling in the sort of coastal areas, we're able to avoid a central air system, expensive sort of central air system, and just use baseboard electric heaters in each room. These are very inefficient heating systems, but we have so little need for heat, we almost never need them. So what happens is, and they're highly controllable. So if we have like a 3-bedroom house, and then we have a living, dining, and a kitchen, so we have some, say, 5 rooms, we can have an electric baseboard heater in each room with its own thermostat, right? Each one of these can have its own. So child 1 likes it at 65 degrees, and and then child 2 likes it at 72, and you get the idea. So though we're using we're using sort of a low efficiency, the unit itself uses a lot of electricity, but is not needed very much, and is highly adaptable and highly controllable. So we're able to heat this entire house for under $10,000. Well under $10,000, more like $5,000. Whereas if we were putting a centralized system in this house, we're at $35,000, $45,000. They're expensive systems. And they're not nearly as controllable. You can't have, we all grew up in a house where there was one thermostat and sort of everybody had to sort of live with whatever temperature the parents set it at. This is entirely different. So we've created a system where we've put money into performance and are able to save money in, first cost money, and your PG&E bill, your energy bill over the use of the structure. So I think you get the basics of low cost, high performance wood frame construction, certainly enough to get you on the right track.